fantastic thing I did. For me it's fantastic anyway, just to avoid it in the future. Okay, but come on, it's not a big mistake. It's not a real mistake at all. It's just something happened and it's no big deal. Okay, so shift cos fraction bar 12 squared plus 18 squared minus 23 squared. You can see if things go absolutely pear-shaped, can you? If they put in a length there that's more than the square, than that plus that, if they put in the impossible triangle, then things will go absolutely haywire. If that number there becomes bigger than 1, it just won't work. But then they've given you rubbish information. That's 24 by 18. So if you can do one of the calculations there, easily do. That's 24 by 18. Okay. Pause there if you like to make sure you have that in the calculator, like so. Oh, didn't close my argument bracket. 98.12. That's in degrees. Now we'll see, does it pass the sanity check? The sanity check is that it's opposite the biggest side and it's the biggest angle, and it's clearly the biggest angle because when you go to being obtuse you are the biggest. So the minute you get an obtuse, indeed once you get 90 degrees or above, once the angle is larger or equal to 90 degrees, make sure it's opposite the biggest length side. Okay, and if it isn't, you've made a mistake. That's question 6. Okay, we're going to question 7 now. Find the smallest angle in the triangles with 11, 14 and 8. That'll be this angle here. Okay, let's not use any letters here, let's just get straight into it. This is the included angle, so the adjacent sides to the angle, so my adjacent sides are 14 squared plus 11 squared minus 8 squared over 2 by 11 by 14. Okay, that's the smallest angle. The calculator shift cosine fraction bar. Just see, maybe would it be worthwhile kind of closing that at the beginning once you're fresh, in case you end up doing all the work and then forgetting to close it, you'll be kicking yourself. So 14 squared plus 11 squared minus 8 squared. So a thing to note is if you're getting the smallest angle, the smallest square will be at the end. Down you go, and I'm looking at 2 by 11 by 14. I'm going to call that 22 by 14. Okay, 22 by 14. Just make sure you don't make a mistake. 22 by 14. Okay, and the smallest angle will always have to be, do you agree that the smallest angle has to be less than 60? Yeah, because you could have one at 60.0001, you could have one incrementally bigger than 60, another one incrementally bigger than 60, and then your one is going to be 59 point, it can be very close to 60 if you have an extreme situation, barely off an equilateral triangle. But 60 is the cutoff, and that passes the sanity test because it's at 34.77 degrees. What happens if I hit that button there? So another way of the exact angle there, at least it is an exact angle, is it? Because it didn't give it. No, it's probably because I'm in decimal. I have a fixture on. Yeah, to 2 decimal places. That's interesting. 34 degrees, 46 minutes, 19 seconds. Do you know what comes next? A jiffy. A jiffy comes after that. That's why we have I'll be with you in a jiffy. Kind of cool. And I just want to see if I turn my fixing off in the number area here. If I go to normal. normal 1, and I go back to that, it still doesn't give me, sometimes it gives you decimals out there. Okay, for example, if I just pick a random number, I'll take E, which is a irrational number, and I just pretend that's an angle, and it gives me the seconds with a decimal place after it. For some reason, whatever way that one worked out, 11, 14 and 8, it seems to have been interesting. It just seems to have been exact, which is quite a surprise. Anyway, there we go. So that's question 7 done. Moving now to question 8. On page 298. Find the smallest angle in the triangle with sides 11, 9 and 7. Okay, getting very easy here. 11, 9 and 7. The smallest angle will be here. So the square root of 11 squared plus 9 squared minus 7 squared over 2 by 11 by 9. Okay, we're getting a bit sick of these now, they're so easy. So that'll be the smallest angle. The square root, I didn't start my fraction bar. I do that now. Yeah. But then pop in there right next to the square, down from it, and continue on. Plus 9 squared. No matter how much you learn, you're going to have to always use problem solving. And the day of your leaving cert, you'll be using problem solving. You won't have done every single question they ask you. You'll be getting shown how smart you are. Times 22 by 7 equals, okay, what have I done? 22 by 9. And anyway, and what else? 11. Yeah, that looks right. And maybe it is very small if you do it in degrees. Hard to believe. Maybe really, really skinny. No, it couldn't be really skinny. That's 7. I mean, it's quite large compared to, you know, it's in the ballpark. So there's something wrong here. What have I done to my camera? My angle unit shouldn't have changed. It should still be degree. Oh, I forgot the inverse cos. And I shouldn't be taking a square root. What on earth happened to me? Oh my god. And this is important. You've seen me make this terrible mistake, and I'll leave this up. Okay? So we use the square root in this case, but not a square root in the other case. Now at least I got this, say I'm in an exam, at least this seems absolutely ridiculous. So you can see slipping into autopilot is something can happen to you, especially when you're doing loads and loads and loads of questions. So 11, 9 and 7, I'll just put it more like this, 7, 9, 11. And the angle, so if there's an angle, there's an inverse cos involved on the, well, there's a cos or an inverse cos involved in either case. So I was obviously completely lost the plot, if you like, there. So this is going to be simply the inverse cos of a fraction. And we start off with the two, so the fraction that we're interested in, we talk about the flanking or the adjacent arms being 11 squared and 9 squared minus the opposite arm over double the product of the adjacent arms. Okay, so it's inverse cosine, and plug that in the calculator, blah blah blah. Shift cos fraction bar 11 squared plus 9 squared minus 7 squared over 22 by 9, and close up your argument. The argument is the thing that's the input to a function, and inverse cosine is a function of sorts. Okay, so that comes out at 39.4 degrees, which is definitely less than 60 degrees, which it must be, and that's good. Okay, nearly there now. Question 9. In the triangle with sides of length blah blah blah. Okay, what we're used to here is seeing a squared is equal to b squared plus c squared minus 2bc times the cos of a. But they're telling us that a squared equals b squared plus c squared minus bc. That means that 2 cos a equals 1. And that means that cos of a equals a half. Now, there's only one answer to that. A equals 60 degrees. Okay, that's question 9 done. And 1 to go. Question 10. In a triangle, if this is true, find and measure. Oh, I have to do a bit of problem solving here. So remember again that a squared is usually equal to b squared plus c squared minus 2 is always equal to b squared plus c squared, not usually, 2bc times the cos of a. Okay, and they're giving us a squared is equal to b plus c squared. Well, we're going to process that. Minus bc. I do see what's happening here. It's kind of cool. So that becomes b squared plus c squared. Normally this would be plus 2bc, and then you've got the minus bc. So this is equal to b squared plus, can you see this? Yeah, c squared plus bc. And when we compare that with this, now very careful, we can see the minus 2 times the cos of a should be 1. Because this is only BC. So minus 2 cos A is 1. Minus 2 cos A equals 1. No? When is cos negative? In that situation. Cool, that's fine. So the cos of A equals negative a half. Now we can do this without resorting to the calculator. Okay, so basically you can get the reference angle there and you'll find it to be 60 degrees. Okay, but we're not in a positive, we're in a negative. So this needs to be 60, making this 120 degrees. You can just do an inverse cosine of minus a half, by the way, and it'll come out fine for you, so you don't need to. You may be, even if you were missing some of the skill I just used there, you could still go minus, oh, hang on, del minus 1 over 2, close your argument, and you'll get your 120 degrees like that says there. Okay, that's the end of cosine rule, and I'll park that up and put that on YouTube.